All right, so now that we have that, we're gonna scroll down here and we can take a look at the schematic here. So we're gonna put on, if you have this orientated as the picture, you're gonna have your ground wire on the outside, your hot wire on the middle, and then your signal wire on the end. That's gonna go into port 11. So we'll wire this up here, signal wire into 11. Ground into ground, and then we're going into the 5-volt. Oops. All right, so when you complete that, you should have it, it'll look like something like this. And then I did post the code in Schoology if you want to access it there. I'm also going to come here and post it. All right, so it's posted in the chat, and it's also live on Schoology in case you need to check it there. So who has their projects wired up? Go in the participants area and react with yes or no. That way I can get a feel for the room and where everyone's at. If you're having any issues with wiring this up, please message me so we can solve those. I'll go back to the page here so that you guys can use that for reference. For students who are who have gotten to this point, what I want you to do now is to go and
are you sure you gave me the right code? Hold on. How am I? Okay, I'm a little confused. Because for me it's showing x-axis and y-axis. Is that correct?
All right, well, let me double check that to make sure I sent the right code, but you can always go into Schoology and get the right code under the lesson plan.
Okay. It says analog joystick.
All right, well, yeah, let me double check. Because I have the code right here that I shared, but
IR remote.
Is it the IR receiver module?
yes. So it
Okay,
looks
that was
like
the first one.
what's that?
That's the code of the first one you gave us.
Okay, that's what I thought. Both of them should be. So you clicked on that first link?
Yeah.
Okay. So now what I want you to do is, if you're at this point, you're going to go over to monitor. And when you run this code, you'll actually see the different buttons that you're pressing. It should come up. So let me take a look here and make sure my serial port is working.
What? I don't think I have the right thing. What? Okay, I'm hella confused.
My computer isn't registering that my board is plugged into the computer. Like it doesn't have like the Arduino COM3 thing that comes up.
So does it have like the little X next to it?
Yeah.
You can try upload or re-uploading the plugin. So that's like going in this help menu right here, scrolling down and re-uploading the plugin right here. I'm not sure why, but that has always fixed it for me. So yeah, like I said, I'm not too sure why that happens, but you can see right here, once you do get it connected, like right now, I'm going to press the number 2. And you can see right here that in my monitor board area, it's registering all the different buttons that I'm pressing. So if I wanted to fast forward, there's my pause, volume up, volume down, and that's just going to log all the different key inputs that you do.
Is this the right piece?
No.
That explains it. Okay.
Maybe. We'll go back to it, Casey. I want to take it looked like a weird angle. It looked like a different part. That's it. Yeah.
Oh, okay.
So to complete this assignment, you'll just need to take a screenshot of your monitor area here and show that you can have different inputs.
You said that like I have to push a button. No. Okay. You said something about pushing a button.
Yes, on your remote. There's a little remote that comes in the kit.
Oh.
Yeah.
Oh
so
my goodness. Big brain.
right here.
Actually, small brain.
Like I said, when I press here, like I'll press the button, and you'll see on my screen that it registers. Right now, it's coming with other buttons, so there's probably an issue with my library, because before, when I was pressing these numbers, I was getting the actual value.
This is the remote, right?
Yep.
Okay. Do I press power first?
No, you can just press whatever buttons you want. It should register. You need to pull up the monitor menu.
Yeah, I've got the.
See what your
It says it's not doing anything. I'm pressing 5. It's not doing anything.
So is your IR module lighting up? Because when you press the button, it should light up red.
Nope, not seeing a thing.
So that means that your wiring is incorrect.
Okay.
When you press that button, that IR signal should receive onto the little chip that we just installed.
Okay.
Red light
flash. Can I see the diagram?
Yeah. Well, I can tell it to you. Yeah, we'll just pull it up.
Yellow goes to 11. Yeah. Red goes to 5 volts.
When you're pointing the remote, you need to point it in the general direction. It's just like how you would use your TV. So
yeah,
be exactly pointing to it, but you know,
ground
like
goes to ground.
I'm testing it right now, and as long as I'm at least 90 degrees with it, so like right here I'm pointing up and it's registering, when I'm pointing it over and my chip is
I'm pointing at it directly. Nothing's happening.
You can also hold it down and you can kind of see, it looks like I have about 180 degrees. So right here at the bottom, it goes away.
It's not detecting anything.
All right, so then that means that your wiring is incorrect somewhere.
So should we take a picture?
Well,
of the
I'm
setup
checking it
then,
and I'm double checking it.
It's okay.
I'm going to triple check it.
What was that, Olivia?
So should we take a picture of the setup and then like the monitor thing with all the different instructions that we put into it? Will that be good?
Just screenshot the monitor because the monitor won't work unless your setup's correct. So
We don't need a picture of the setup.
No, that's just an easy way.
Code is running.
So Casey, so you need to make sure that the positive, so the 5-volt is going to the middle.
Yeah.
Ground is going to the left side, and then the right side is going to port 11.
Yep, that is exactly how it is. I have triple checked.
Are you getting the lights on the board? So is it plugged into your computer?
Yeah, I have a little lime light and an orange light.
Okay. I'm trying to think. And you're definitely on. You have the IR module code pulled up.
Yep.
Okay. So why don't you share your screen and let's take a look at the code that you're looking at, and we'll see if we can troubleshoot from there.
It's running.
It looks like it's working because it says other button.
Yeah, I don't know what that means, but like I'm pressing 5. Nothing is happening.
Okay, so it tells me that it was working at one point because you were receiving some signals from your remote because you're
I don't
getting.
know what other button means though.
All it just means is that, so this button has a number attached to it. And if you look right here, see how it says #include iremote.h? I'm guessing there's an issue with the library where it's receiving that input and it's not translating it. That library translates this code into like what it actually says for us. So like, for example, 128666925 might be the number 5 for programming purposes, but for our purposes, that doesn't make any sense. So that library converts the numbers that the board is recognizing and converts it into a number that we humans would recognize. So I'm guessing it's just an issue with the library not connecting.
Okay.
I guess what I would suggest is unplug everything and plug it back in, because maybe there's somewhere, well, not your board, but the stuff, the little circuit board here. Just unplug everything and plug it back in, and make sure that you have firm connections. Like you can't pull it. Like on mine right here, like if I just tug it a little bit, like nothing happens. It's not moving around. And make sure that all those are attached and they're plugged in. Also, make sure you're in the 5-volt and not the 3.5 volt.
Definitely in the 5-volt.
See, so right now you're getting buttons. See that? So press your button.
I'm not pressing any buttons, and it was straight up unplugged.
But you just plugged it in a second ago. So try pressing some remote buttons while pointing it there.
Pressing several buttons right now as we speak.
And you're pointing it at the receiver?
Directly.
Okay.
And I'm not seeing any light.
Oh, did you pull the battery clip out of the remote at the bottom?
You mean this weird plastic thing?
Yeah, pull that out.
Pull that out?
Yeah, your remote doesn't have any battery power. Now it should have battery power.
Yay!
So there's a simple solution, folks. His remote didn't have any battery power because he didn't pull that little tab out, which separates the connections. So when it's sitting in a box for a year, it doesn't drain the battery. So if you're having similar problems as Casey, now maybe you can look there and figure out why it's not working. All right, so go in your reaction area and respond if you have finished this module. All right, if you have not finished the module, can you send me a chat and tell me what is not working, or what step you're at, so we can get you there. For students who are finished with this, we're going to move on to the next one. So you can go in Schoology and open up lesson 14. And why don't you get started on that at your own pace while I help some other students out that need to finish the lesson 13. So lesson 14, just giving you forewarning, uses a lot of stuff. I think it uses 16 jumper wires. It uses that LCD display, and then there's a potentiometer. The potentiometer is stuck into one of the little foam blocks that you get with your kit. And there's also going to be a black dial knob that you need with it. So this black dial knob I found in the bottom right-hand corner of the bin. And that's also where the potentiometer was. And see how it's this little black thing, and it's in a little foam block, so you need to pull that out to use it. Then you'll take your black knob and you will stick it in there, and that'll allow you to turn this and set it as a potential and set the values.
What page is the 14 on?
Lesson 14.
99.
Yeah.
All right, so I'm looking here and I see a lot of students who have not responded with a yes or no reaction. So if you could please do so I know where you're at. Also, if you're not finished with this, can you please reach out so that we can figure out what's going on so you're not stuck? All right, since I haven't heard from others, we're gonna move on, and I'm guessing that this is working. So here we go. All right, so lesson 14, the LCD display. So you're gonna find this board right here, which is the LCD display. You're gonna need one potentiometer. You're gonna need the big 830 breadboard. You're gonna need 16 jumper cables, and then you're gonna need obviously your Uno board. So here are the different definitions for on the LCD screen. Each one of these has like a little abbreviation, so you can see what each one of those does. So when we scroll down here, we can see the wiring diagram. So Noah's asking about pushing the breadboard and the LCD screen together. So it's kind of difficult, but odds are you're probably not going to break it. I mean, I didn't break mine, and I thought that I might have. So you can see right here, I just pressed mine in. I think that just since there's so many different pins, I think there's 16 pins there. Just the combined force as you're going through and trying to align everything. So I find it best to kind of press right above the pins as best as you can. And once you kind of get one corner in, the rest kind of fall into suit. So the methodology that I did when I was building this this circuit was I started on the right here and I just started building over. So first thing I did was I put the potentiometer in, and then I waited to put this yellow cable in because this yellow cable has to align with the third pin. So that just kind of depends on where your LCD screen ends up. So then I put my hot and then my ground in on the common positive and negatives. And then I decided to put my screen in because that determines where the rest of all these guys go. So once again, just kind of pop it in there. It's the other thing I noticed with the potentiometer is the actual plastic bottom isn't going to rest on the breadboard. It's going to be slightly above. The pins stop it from going all the way down. So don't think you need to press that down a whole lot. I'd say there's probably a 1/16 inch underneath the bottom of mine. So then you just put in your negative and your positive. Now you can put in your yellow cable and then go from port 7 to 8 right there. You've got this ground right here. So all I just did was I went to the right and left, or I started on the right and moved over to the left and put each pin where it belonged until I got to the end. And once you do that, then you'll have everything successfully wired. And then we just have one 5-volt wire coming all the way from here to give us charge on this. Casey, how's that going for you? Good. That's good to see.
I can't find the potentiometer.
The potentiometer is going to
Yeah,
be,
potentiometer.
it's going to be in a little foam block in that bottom right-hand corner. And then you just have to like kind of pull it out of the foam block. Let's see if I can find where mine is.
I don't think.
Were you able to find the little twist knob?
Yeah.
Okay, so it's in that same area, and there's just a little, like I said, a little foam block that
The
is.
only foam block things I have are these.
Yeah, there should be one more floating around. I
No.
just had mine. Oh, there it is. So it should look like this. So you'll see the potentiometer looks
Your
like,
camera's off.
so it'll look like this.
Yeah. And then see that. I don't have that.
Double check. Like I know I found mine. Mine was in the bottom right hand little corner block. And it was right next to where the little dial is.
Yeah, I've looked in every container thing.
Yeah, you might have to look through
No,
the stuff that you've already taken out, because there's a lot of parts in this kit. And I know when I went to go find my kit that I've been using for a while, it took me like probably 10 minutes to find it. It could have fallen out of the foam, and then you don't have that foam anymore to kind of identify it. When there's no foam on it, it looks like this. I don't think it'd be the end of the world if you didn't have the potentiometer. Is everything else wired, Olivia? So if everything else is wired, then you can probably still run the test code. What the potentiometer does is it adjusts the how bright the screen is. So without it, it would just be as bright as it can go.
Okay.
Can you post the code?
Yes, I'm doing that right now. So let me go to my sketchbook. All right, so in the chat area, I have the code posted for the LCD display.
I don't see it. There. I see it now.
Yep, so you click on that and you should be able to run it. Let's see. So a comment, like the first time I ran it, I was like, did I break it? It's not working. Make sure that your potentiometer, why don't you like try twisting it, twist it all the way to the right if you can't see anything, because that will change the display and that will make it look like if it's turned all the way to the left, you won't be able to see anything. So for this assignment, you're going to take a picture of what it looks like when you run the code, and then you'll have to write your own printout.
What do you mean?
I'm going to go through that in a second. First, you got to run the code, and then we're going to analyze the code and see how to
I'm not
change.
even close to being done wiring it up.
That's okay. Noah, were you able to get your LCD screen in?
Is the screen just supposed to light up, or is there supposed to be words on the screen?
So it will light up. Are you running the code right now?
Yeah.
Okay. So that's maybe we do end up needing that potentiometer. So let me take a look. So yeah, no, it's probably just not in all the way. So you just need to press it in. Like I said, it seems like it's gonna break, but you'll be okay. So I'm going to take a look at the code here and see if there's a line that we can change, Olivia, for that potentiometer.
Even with it, I'm not seeing anything on the screen. It's just lit up.
Turn it all the way to the right.
What do I like turn on it?
What's that?
What do I turn on it?
There, the potentiometer, there's a little black dial it comes with that you have to like kind of plug into it. It looks like this.
Oh, okay, I see.
So find that, and then you can adjust that value. All right, so Olivia, what I think that you would have to do is you'd have to put a 10K resistor there in place of the potentiometer.
Okay.
But yeah, let's see. Try to look for it more because that is want to make sure that we're doing that right. Yeah, because that's a 10K potentiometer. So what I'm guessing is that has a 10K resistance. So if you ran, but the trouble is that goes to a single pin. So yeah, so just look for that some more and see if you can find it. Because right now what I'm guessing is you have it just turned all the way off because you just see like a blue screen, right?
Mr. Schwartz,
Yeah.
how do I put the LCD screen into the board?
You got to press it in.
Oh, is it just you just press it real hard?
Yep. Like
Okay.
we were talking about that earlier. It seems kind of sketchy. You're like, but you just got to press it in.
Okay. Thank you.
And then just align the pins from there. So yeah, so you should see words on the screen. You'll see right here when we go into our code, you'll see we have LCD print. So this is what it is going to print there. So if you
You
change,
said to not take this apart, right?
don't take it apart, because the next one we add to it.
Is the next one just changing the letters?
No, it's not. We add another component that reads out on the display. So for your assignment, once you build this, you're going to come in here on this lcd.print, and you're going to change this to a phrase that you want to do. So right here, right now I have mine's reading out pineapple over all, or is less than all. And so you'll also notice that you only have 16 characters to type on that screen, because you only have one line to print out on. So you'll have to keep it somewhat short. But you could write, you know, go Seahawks, if that is something that you like, or whatever it be. So I want you to change that print. So you need to take a photo of what the screen is showing originally, and then you need to take a photo of you editing it so that it says your new phrase. And that is how you'll submit for this assignment. Also, you'll notice that we have a second loop going underneath on the second line of your LCD screen. And that is just a timer loop, and that's telling you how many seconds the code has been running for.
Mr. Schwartz,
Yeah.
can I see the sketch one more time, or the picture?
Yep. Here it is. Let me put that in full screen for you. There you go.
Thank you.
Yep. Olivia, are you still looking for that potentiometer?
Yeah.
Oh man, that's fun. Yeah. I know it's not in a bag, so it should just be a free floating part. It's got 3 prongs on it, 2 on one side. It's got that white center. Maybe also when you open your lid, there's a picture of all the different parts that are available, and you can look at the potentiometer picture and see if maybe that'll help you find it.
Yeah, I can see that picture.
The next part that's going to be hard to find, well, actually, if you don't know where to look for it, is the thermistor. It's a very, very small pin, but it should be in the same bag as your switches for students going on to lesson 15.
What do I do, like, if I can't find it?
Let me experiment really quick and make sure that you're not going to fry anything.
Okay.
So let me test it out on my board first.
How many characters do I get to put in?
You get 16.
16. Okay.
So just want the current. So plug this in here.
It's not working.
Is it lighting up at least?
Yes, it is lighting up.
So turn your potentiometer all the way to the right.
I don't know what that means.
So install the little thumb dial and turn it all the way to the right.
What's a thumb dial?
This little black knob that you insert into the potentiometer.
I don't know what to look for. Wait. Oh shoot. Is it?
A small black cylinder.
Wait. This.
Yes. Plug that into the potentiometer and then you can turn it.
Turn it to the right. Oh, saw something.
So as you turn it more to the right,
What is this green supposed to say?
Oh, it was there for a sec. It's flashing. There it is.
well, it depends what you have in your print section.
Mine says backslash question mark space question mark, and then the last character keeps changing.
That is
It's
definitely
really sketchy, but yes, I got it. Oh, okay. If I just press down on it, it will show.
Still having trouble with this little guy.
LCD screen a little bit more, Casey.
Okay.
Nope.
Now it says pineapple
Camera shot.
less than all, and then just a number counting from 1 to 12.
Okay, that
0.
should be.
There we go. I got it.
Okay, where is it?
Right.
All right. Oh, there it is. Okay.
Can you post the code for the last one?
Yes.
Also, it's extremely stormy out, so if I lose connection, that's why.
Oh yeah, it's like
Yeah.
monsooning.
Yeah. So yeah, Swartz, if you lose like 15 students at once, that's why.
Yeah, we've been through it before. Right now we're going. I mean, this is being live on YouTube, so worst case. I mean, all the assignments are already posted in Schoology, so if you do get disconnected, you at least know the page numbers and can follow along. Yeah. So, I'm trying to think. I'm trying to figure out why I need a potentiometer to run this, Olivia.
Sorry. I should mute myself.
Maybe, let's see. So, because I tried it at I plugged it directly in at 5 volts and it didn't do that. And then I did a 10K resistor and it still didn't like that. So we want the all right, so the VO pin, which is what the yellow one is plugged into, it adjusts the contrast. So we need to be able to adjust the value coming in. So I'm guessing that the greater the resistance, the more contrast we're going to have.
Swartz, can you post the code for lesson 4 or 15, whatever it is?
Yeah.
So lesson 15 is just changing the text on 14, or is that different?
Lesson 15 is creating a thermostat.
Uh,
And what you guys are going to be doing in lesson 15 is once you get up and running and it's reading the current conditions, then you will have to change it from Celsius to Fahrenheit by commenting out some code. So if your LCD is not printing out anything, then you need to adjust your potentiometer. So we're going to go back here. So your potentiometer is, we're going to get a photo of it, is this right here. And you're going to take that black knob, you need to install that and then turn it all the way to the right to get more contrast in the board.
Should we go to lesson 15?
I just messed something up.
If you finished the lesson 14, yes.
Okay. What's the thing on the left with lesson 15? I don't know what that is.
That's the little thermometer pin.
Oh,
The
where do I
same
find that?
as the switches. It's really small.
Really small, of course.
Oh, God. Well, this stuff is burned.
What did you do, Dylan?
What's that?
Sounds like you're throwing.
Who is throwing?
Oh, my mic's unmuted. I'm talking to someone while I'm putting this stuff together.
Hmm.
Damn.
I can't find the thermometer. Where would I find it?
It's going to be in the same bag as your switches.
Switches. You mean the little buttons?
Yeah, little push buttons.
Okay.
Where's the little pin?
I don't think this is it. Is it?
Hmm.
Is it this?
Let me see. No. It's like really small.
No way is it that. Oh my
It's like
goodness.
little, like,
It just looks like two metal things with a piece of plastic dotting the top.
Yep.
Okay, I think I messed up somehow.
Is it this?
Yes.
Oh my gosh.
So I got it to print, but it's saying my temperature is 475 degrees Fahrenheit.
Mm-hmm.
So
I think it needs to normalize. So, like, for example, if like you've been handling it, so if you put like some moisture in it, that could affect it. Like when I first did mine, it was saying it was like 90 degrees.
Red resistor.
But now that I've
Yellow
had
wire and a red wire.
it's like 23 C, which is a little bit more realistic.
it's just
Got a
sitting
yellow
at
wire.
475, and then when I touch it, it goes up to 525.
Well, actually, do you have the right resistor? Are you sure you don't have? Because the resistor is what is going to calibrate that.
I believe I have a 10K.
Because I feel like if you don't have a 10K, then that's just going to amplify your number value, the value that you should have.
10K resistor.
Maybe the thing isn't in all the way.
I think if you're getting readings, it is in all the way. It's
Well, I took it out and the reading did not change.
Interesting.
5K, 100K,
Olivia, we're
something M,
no, you're still striking out.
1K.
Yeah, I'm just sitting here because I
Okay.
can't do anything.
Are you in Woodinville?
Ah, 10K.
Yeah.
Okay. Because I have a few spare ones, and I could drop one off so you can complete the projects.
Yeah. I
it
live
wasn't
like
in all the
3
way.
minutes away from the high school.
You live what?
I live like 3 minutes away from the high school.
Well, at the end of the class period, I can put it in a little baggie and put it like in your mailbox or at your door or something like that.
Mm-hmm.
Complete it. Now,
Okay.
if anyone else is having issues like that, you can you please let me know if you like can't find something, or if you don't have a kit, or like anything along those lines that doesn't allow you to do your coursework. I'll figure out a way to get it to you. So, Olivia, why don't you go into the lesson 15 and wire that up? Because even if it's wired up, you can bounce back between the lesson 14 and 15 codes and do both projects, and then you're just waiting to plug the potentiometer in.
Okay.
So to turn this in, do I just take a picture of the reading?
Yeah, so I found that if you don't have it all the way to the right, if you kind of dial it back so it doesn't have the grids, you get a little bit better picture quality, because the contrast isn't super high. So we're gonna go into a little lesson here. If you're stuck on the building section, we can at least look at this part right here, and we can go through the code so you know what you need to do when you get to that stage. So we're in the thermometer code here.
Why?
So at the bottom here, you can see like Elegoo does a really good job of commenting their codes so that you can understand how they code it. And right here we have / display temperature in C. So that is how it's going to come, and you can see that right here. We don't want to get rid of these backslashes because this is just our comment. But for example, if we wanted to get rid of these right here, all we'd have to do is put / and we can comment that out. And then we want to come in here and comment back or uncomment display temperature in F, and then LCD print temperature in F. And then at the bottom here, again, we'd want to backspace or / those, and then come back and delete those to bring this plain F.
I'm having a bit of a problem.
What's that?
Yeah,
Either
so
I'm a monster or something is bugging out because it is showing the temperature as being roughly -75 degrees Celsius.
Okay, so
I don't think it's right.
did you hook your resistor up right, or is it shorting somewhere? Or is it possible that we messed up right here? Because when we look up here, you can see that this is actually measuring in Kelvin, and then in our code, we're actually converting from Kelvin. So if your values are different from here, then that could mess it up.
I mean, if it was Kelvin, that'd be even worse.
No,
Because negative Kelvin is impossible.
no, but I understand that, Casey, but I'm just saying that maybe you added a 0 or a 1 somewhere by accident.
Look, I didn't even touch the code.
Okay, but I'm just trying to say like why you might have an issue with your code. Okay.
Is it the resistor?
It probably is the resistor. Make sure you have a 10K resistor, not 100K.
Okay.
But
I mean, it was in the 10K part, so I assumed it was 10K.
Well, maybe you read it wrong. I think there was like a 10K or something like that. There was like, or it was like a weird. I can't remember which one it was. Let me look here. But
Definitely just says 10K.
Okay. Well, I just remember reading that there was like a weird one.
Wait, I need to see the diagram again. I'm sorry.
You can pull it up.
yeah, this.
You're fine. I'm just looking through.
Wait,
here.
yeah, you're right. Okay. Yeah.
All I'm saying is that if you look at the methodology of this code, what this sensor is doing is it's reading in Kelvin, and then they created two different conversions that we call on to get our temperature. You can see we have two different equations here, and you can see it converts Kelvin to Celsius and then converts Kelvin to Fahrenheit, and that's what we're using down here when we're displaying those. So
It's still showing the same values.
I can bring back the sketch here.
What if I use like the ohm resistor,
What do you mean the ohm resistor?
the 2200?
I wouldn't do that. I would do what they call for. So you can see right here, this is the wiring diagram that you should have set up.
Yeah. Bingo.
So we've got our resistor going into the negative side. We've got our, I don't believe that these have a positive and a negative. I can double check up here, but it didn't have any diagrams showing that.
Okay. Should I try 1K?
No, you should use the ones that they're suggesting.
Well, the ones that they're suggesting are giving me negative numbers. I'm gonna look for 10K again.
Okay, I'm kind of stuck on this one.
330. 1K. The 10K that didn't work. 2K. 100. 10 million.
Okay. This is
No, I've been using 10K.
Make sure you're not using 10 mil instead of 10K.
Fine. Why? Okay. Where is
See. So I want to see what type we have here.
What were the code changes we had to do for the thermometer?
You just had to
Boxes
change
and
it
stuff?
from displaying Celsius to Fahrenheit. So you just get rid of some backslashes and add some more. Comment out and decomment the code.
what am I missing?
So we're using an NTC, I'm guessing, since we're using this for temperature measurement. So if we're using an NTC,
It says that the display was not declared in this scope.
all right. So I think that you commented, you got rid of some backslashes that were meant just to be a comment. So I believe like right here, you might have, like this guy right here, you went like that.
Oh, yeah.
Yeah, this is just meant to always be a comment. So that it's like, okay, if you want to display in C, then you need to activate these ones.
Okay.
Well, we'll go with, if you're getting a value, we'll take that as a win, even if your value is really off.
You'll accept that?
Yeah.
Okay.
Troubleshooting these kind of problems is really difficult online. If we're in person, it might be easier to troubleshoot why that's happening. All right, so let's get a read for the classroom. Where is everyone with this right now?
Well, since you said you'd accept really off values, I've finished everything.
All right, that's good to hear. Can you give me a green check if you have finished lesson 14, which is getting the LCD display to print out a phrase?
No. I'm so far behind. Okay. I might have accidentally broke something. But Jesus, how much does this cost?
Now my thing says expected primary expression before slash token.
Um,
And it's like highlighting a certain line 30.
So why don't you share your screen and we'll take a look and look at that error.
Okay.
Okay, so all right, so put 2 backslashes in front of
There we go.
and then you should be fine.
Which one? This one?
Yeah, in that line, that was supposed to just be a comment.
Yeah.
Okay. I think it would technically be working now, but I just don't have words on my screen.
Yep. You might even go into monitor and see if you can at least see if in the monitor it gives you the values it's supposed to be displaying. So run the code again with monitor pulled up.
Okay.
Okay. Yeah, so just wait until we get that potentiometer to you. As long as everything's ready to go, you should just be able to plug and play it and then be good to go.
Okay.
Wait, so once we're done with the 14 and 15, are we free to go, or are we doing more things?
Yep, as long as you've got 14 and 15 or 13, 14, 15 done, then you're good to go. So you'll see in Schoology what you need to do to submit those. For students in the advanced class, I'm doing that. I'm bringing that into your course right now.
Thank you.
Instead of saying Fahrenheit, mine says temp.
It should say temp, a number, and then C or F.
It says
All right.
temp 73 point blah 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 temp.
Does mine say that?
Mine has a C or an F at the end of that.
Yeah, mine doesn't.
All right.
I also had mine say temp.
Interesting.
I wouldn't be surprised if mine said temp.
I think maybe at the bottom. So if we look at this section of code, I think you just ran out of characters for some reason. But if you look right here, you can see LCD print temp F. So I'm guessing it's trying to print this out, and then you're just missing that F character.
I still have a box left.
What do you mean a box left?
Like every letter takes up a box. There's still one at the end.
Well, yeah, I'm not sure why it's doing that. That's just my hypothesis as to why that might be. Because it's the only place that we see temp, or like right here. Oh, you know what might have happened? See it right on this line right here? If I hit my space bar. So double check that your code wasn't like that too.
Oh, mine was like that.
So see what, so that it bumped it out. It's just, it should be like that.
Okay, thanks.
I'm guessing I set something down on my computer and it bumped all those space bars out.
Since I've done everything, can I leave?
Yeah.
Okay.
See you.
Thank you. Bye.
Yeah, now there's Fahrenheit. Thank you.
Awesome. All right. So if does anyone else need any help? If not, I'm gonna. Antone, what's up?
First of all, I think I just broke something, and now I cannot fix it.
That's a bummer. What do you think you broke?
This, let me share my.
Let me. I'll let you share your screen.
Okay, this little guy right here. You see it? Yeah, that's it.
So what is that? Your potentiometer?
Yeah, like it was overheating. I tried to pull it out.
It was overheating.
Yeah, it was like.
So if it was overheating, maybe we plugged something in wrong.
Yeah, that's what I'm trying to fix.
All right. So can you want to show me your board really quick? Because I can get you another potentiometer, and then you can do that. But you know, if the same problem is present, then that you're not going to be able to fix it.
Jesus. Okay, well, this is.
All right. You want to rotate it so I can look at it like from an overhead view?
Oh.
Yeah. There we go. It kind of looks like that. All right. Thanks. So you had it right there and there. I mean, that looks right. Let's see, you got red going down to there. Yeah, it's interesting. I don't know why it would have done that. It's plugged into 5-volt. Yeah, I'll just get you another one and we can try that again, okay? Were you able to figure out how to get your computer to run code?
Yeah, it's already like the icon is already in the computer, so I'm able to access.
Mm-hmm. Okay. I'll follow up with our SDS person because I sent her an email. I didn't hear back. I'll send another one to get you a Mac.
Okay. And I'm also having trouble connecting this. So
Yeah, that LCD board is kind of difficult.
yeah.
You just gotta commit and press it in. I promise it'll work. If not, I'll get you a new one. But I didn't break mine, and no student that did this project broke theirs either, so I think we'll be okay. Ryan, Tom, you guys good?
So I took the picture of of 15. Well, it still said temp twice, and because I thought that was what it was supposed to do, I started disassembling it. Do you want me to put it back together so I can have it say F?
What did I say at the beginning of class, man? What I say?
Well, you said to not take it apart, but you don't take apart 14, so I didn't. And then when I thought I was on a 15, which was the last thing, I started
Mm-hmm.
putting my stuff away.
Well, I'll tell you what, man. Don't take stuff apart. I mean, it looks like for the next one we're fine. It doesn't look like we're using the LCD display on the next one, so you'll be okay. What I'll have you do if you don't want to rebuild it is you can write about what your mistake was and why it was just reading temp.
Yeah. I've been taking apart the stuff in between classes because I have a cat that comes in my room and I don't want him to like tear apart the cords and stuff.
Oh yeah. Well, maybe you can put like a little tote bin to put everything in.
I guess I'll figure out what I can do about that.
Yeah. No, you should be fine. Like I said, if you just write about like what your error was, that's just as good as you putting it back together and fixing it.
Okay.
Goodness.
You'll notice that in my picture it says temp, and then there you don't know the measurement type, and that's because and then you'll write about why your code was written like that. So, all right. Ben, are you looking good? Ryan, you
Jesus Christ. I'm so clumsy today.
all right, Anton. When I hear back, I'll let you know.
Fuck. Okay, that's fine.
So when I hear back, Anton, I'll circle back with you and let you know what I heard. I am going to stop this. Yeah, Olivia, I'm going to run that over to you really quick. And that way you can finish this up, and I'll try to do that before advisory. I'm actually at school right now anyway, so.
Okay, thank you.
Does anyone else need any help? All right, if you do need help, guys, just reach out to me so that you can come into the advisory, or we can meet on like a Wednesday. Whatever time really works for you, so that we can go from there and help you out whatever it is they need.
Thank you.
Okay. I guess I can join your advisory on Wednesday.
Advisory soon, so we'll get together. Like I saw the photo you sent earlier of the first lesson. Looked great, so that's good to see.
Okay, yeah, now I'll work on the 15 or the 14. Yeah, 14.
So do you need another potentiometer as well?
Oh, and there's the last one. Yeah, I found another one.
There should only be one potentiometer that you have. So if you need another one, just let me know. I think it looked like you broke your last one, right?
Yep, on accident.
So I will get getting you that when the computer comes in, okay? All right, I'll see you guys later.